Alright, so today I'm going to be solving the problem that I was assigned. So firstly, I'm going to set up a balanced chemical equation and state the reactants of the products. So we know that sodium hydroxide is going to react with copper sulfate, and this is going to produce sodium sulfate, and it's going to produce copper hydroxide. Then to balance this equation, we just add the coefficient of 2 right here. So the first thing we've been asked to do is determine the number of molecules of copper hydroxide. So we've been actually given some information. Now there's 0.025 liters sodium hydroxide and 0.350 is the molarity, 0.045 liters of copper sulfate, and the mole is 0.125. So we're going to then use an equation to determine the limiting reactant, and the reason we use this equation is because we need to know which compound will be used to build our ratio. So this equation is N equals M times V, so N is equal to 0.025 liters multiplied by 0.350 mole per liter. So as you can see here, the liters cancel out, so you get N is equal to 0.00875 mole. But there's a coefficient up here, so we have to divide it by 2, and we get N is equal to 0.004375 mole. Now we use the same equation for copper sulfate, N equals M times V, so N is equal to 0.045 liters times the molarity 0.125, so N equals 0.005625 mole. You divide that by 1 as it's the coefficient, N is equal to 0.005625 mole. As this one is smaller, it's the limiting reactant. As this one is larger, it is the excess. Next up, we're going to build our ratio. So as this is the limiting reactant, we know 2 of NaOH. We put that over 1 CuOH, and that's equal to number of moles, and then we're solving for the number of moles of CuOH. So then we cross multiply, and we find out that the number of moles of CuOH is equal to 0.0875 divided by 2, and so we get the number of moles equal to 0.004375. Lastly, we'll use Avogadro's equation. N is equal to Na, which is Avogadro's number, so number of molecules equals 0.004375 multiplied by 6.02 times 10 to the 23. So that means that the number of molecules is equal to 2.63 times 10 to the 21 molecules. So that's the number of molecules right there. For the second part, we're going to determine the concentration of sulfite ions after the reaction. So first we solve for the number of moles of NaSO4, so NaOH over NaSO4 is equal to, and we already have the number of moles from before, 0.00875 over the number of moles of Na2SO4. So we get the number of moles of Na2SO4 is equal to 0.004375. As this is broken into water, we know that 2 sodium plus SO4 will be equal to Na2SO4. So as we can see here, they have the same coefficient, which means that the number of moles of SO4 is going to be the same, so 0.004375. So then we can solve for the molarity. Molarity is equal to the number of moles, so 0.004375 mole, and then you add the number of liters together, so 0.025 liter plus 0.045 liter. So you get molarity is equal to 0.004375 mole divided by 0.07 liters. And so you get that the molarity is equal to 0.0625 mole per liter. Therefore, the final answers rounded to 2 decimal places are 2.63 times 10 to the 21 molecules, and 0.06 is the concentration of sulfate ions.